Deep in Colombia, the Cerrejón open-pit coal mine is a hyperactive industrial zone. It is a barren, dusty landscape, entirely devoid of life. Every single day, massive excavators tear into the ground, moving hundreds of tons of earth and rock. It is the absolute last place on the planet you would expect to find a record of the prehistoric world. But during a routine geology field trip, a student walking along the exposed mine walls noticed something strange embedded in the rock. There were clear impressions of ancient leaves and seeds. Researchers began digging deeper into this specific spot. Along with the plant impressions, they pulled out massive, heavily fossilized bones dating back to roughly 60 million years ago. Based on the location in South America and the immense bulk of the bone fragments, the scientific team made a logical assumption. They figured they had unearthed the remains of a prehistoric crocodilian. By classifying the bones as a giant crocodile, a find that would rewrite post-dinosaur history was filed away as a routine discovery. The fossils were eventually shipped north for study at the Florida Museum of Natural History. A resident snake expert began unwrapping the protective casing around the remains and immediately froze. Looking closely at the anatomy, something was biologically wrong. The physical geometry was off. The specific curvature and the interlocking joints of these fossils completely contradicted crocodilian bone structure. These fragments did not belong to a crocodile. They were pieces of a serpent's spine. Biologists ran the math based on the width of the vertebrae. The calculations produced a snake roughly 42 feet long, weighing over 1,100 kilograms. A snake of this scale defied the established biological limits for reptiles, forcing a total reassessment of how large these animals could actually grow. To see the mass of this beast, we can look at this scale comparison. The green anaconda is the heaviest snake alive today, maxing out at roughly 8.5 meters. Next to Titanoboa, it is completely dwarfed. At its widest point, the diameter of this serpent would easily reach the waist of a standing human adult. The roadblock here comes down to basic biology. Snakes are cold-blooded. They cannot regulate their own internal body heat. Their maximum physical growth is strictly dictated by the external temperature of their environment. This paleothermometer gauge shows how a reptile's size is restricted by heat, allowing scientists to calculate the ancient climate. Applying this to Titanoboa, they found that to survive at this massive volume, global temperatures had to sit squarely between 30 and 34 degrees Celsius. That is up to 8 degrees hotter than the warmest modern tropical forests. The ecosystem surrounding this snake was a sweltering, hyperhumid greenhouse world devoid of any winter season. Titanoboa functions as a massive living metric. Its existence proves that 60 million years ago, the Earth operated under an intensely hot climate system that we no longer see today. Because of its size, scientists initially assumed Titanoboa hunted exactly like a modern anaconda, slithering across land to ambush and constrict large terrestrial prey. Then, a 2011 expedition returned to the Colombian coal mine and uncovered something incredibly rare: 3 fragile, nearly intact Titanoboa skulls. The skull anatomy ruined the land hunter theory. The specific arrangement of the jaws and the high tooth count showed it was not built for crushing land mammals. It was actually an aquatic ambush predator. It would sit perfectly still beneath the murky, tannin-stained water for days, waiting for massive fish and early crocodiles to swim too close. This aquatic diet shows Titanoboa had adapted to thrive within the specific constraints of a waterlogged, high-temperature ecosystem. Despite its status as an apex predator, Titanoboa eventually disappeared from the fossil record. We know how the dinosaurs died. A massive asteroid impact caused an immediate collapse. But Titanoboa thrived millions of years after that event. No asteroid killed this serpent. This timeline graph outlines the 2 leading scientific theories for its extinction. It shows a stable climate plateau splitting into 2 extreme scenarios, either a sudden cooling event or a massive thermal spike. Whether the global temperature plummeted or skyrocketed, the mechanical cause of death was the same. The baseline environment shifted out of the precise temperature range the snake required to survive. Titanoboa relied on a highly specific, sweltering climate. Its deep specialization allowed it to grow to massive sizes.
But when the global temperature finally broke, that specialization became a fatal trap. It is a reminder that no matter how dominant an animal is, it cannot outlive its environment.